Good afternoon. The purpose of this presentation is to show you an application offered by Sol-Gel technology. How to improve abrasion resistance of silk fabric by Sol-Gel coating. But before we discuss about how to do it, let's see what Sol-Gel is. Let's consider the chemistry of polymer not based on carbon but on other elements able to make a polymeric structure. The most known, the most used is silicium. It is able to make big polymers where the silicium atoms are united together through oxygen bridge. The precursor of this polymer are organic silicate. This is the generic formula, where are alkylic groups, ethyl, propyl, that are lost by hydrolysis, and the silan polyol, which is the monomer, will polymerize, giving the bonds silicium, oxygen, silicium. But if we start only from this precursor, we don't have a wide range of different polymer we can get. We must see better them, because from them we'll derive the properties of the final polymer. So let's see what kind of precursor we can use. This is what we already saw. It's the tetra alkoxy. But we can have the 3 or the D. The difference is that in this case we have 4 points to grow up the polymer. Here 3 and here only 2. Only 2 means linear polymer. 3 or 4 means reticulated polymer. More means more reticulated. X are other groups that will impair special properties to our polymer. Maybe they could impair reactivity. We just put a reactive group, a group able to make chemical bonds with other substances or substrates. But let's start making the sol. Usually precursors are oils, not mixable in water, and very often a lot of people propose to use them in dissolved in alcohol, but this kind of application is not for us, because we want a chemistry more clean, more safer. If we hydrolyze our precursor, the alkylic groups will be replaced by hydroxy group, and hydroxy group will give us more miscibility. If we start a first partial polymerization, we can obtain the small particles of polymer. This line is a line made with SeO, SeO. Let's say I said a small particle, let's say not more than 100 nanometer, characterized by the fact this particle is surrounded by hydroxy group. These hydroxy group are strong solvatant groups, and therefore we get a colloidal dispersion, the sol. The sol looks like water, let's say. I mean clean, transparent. The particle is very small, too small to see. The viscosity is negligible because the degree of polymerization is very low. But our prepolymer is only the beginning. Particles of prepolymer can bond together, and by this way the polymer can grow up. In this case, if the polymer grow up, the appearance change. It becomes a little bit whiter because the size of the particles now begin able to interfere with light. But mainly it becomes more viscose because we increase the degree of polymerization, and the polymer still remains soluble. Well, we can get two different kind of chains depending on the precursor we choose. Linear chains. Linear chains means soft, flexible. This is a chemistry we already know. This is the chemistry of silicone oil, of silicone softener, or we can get a very reticulated, cross-linked chain. In this case, the polymer will be very rigid, hard. Depends. In this case, we have mainly silan diol. In this case, we have mainly the 3 or the tetra substituted. Polymerization continue, and our polymer, no, we cannot call it sol. It's look like a gel. Our sol has become a gel. At the end of the polymerization, when water is completely removed, we obtain a solid, the final polymer. But we're not interested in the polymer itself alone. We are interested in the polymer on the fiber. How to fix it to the fiber? We should put in the polymer, choosing the right precursor, chemical groups that impairs affinity to the fiber, or groups that are able to react with the fiber. Affinity group. Affinity means quaternary ammonium groups like softener. Reactivity could be epoxy group, could be triazinic group. The chemistry of triazinic group is well known about reactive dye stuff, and it is very interesting. And by this way, we can bond the polymer to the fiber. Here I write silk. Why? Because silk is a very interesting fiber, and silk is nice, but has a poor resistance to abrasion. It's nice, it's very expensive. Market wish to have a abrasion resistance silk, mainly for furniture, because if we consider the top quality luxurious furniture, very often their silk is very appreciated. But again, silk has a poor resistance to abrasion. That means abrasion is a critical parameter. Very often a sofa lasts as long as no abrasion appear on it. Not only maintenance of furniture made with silk usually very soft, maybe only soaking, no less, no more. That means we don't have troubles in giving extra properties to our finishing. Application of the sole is very easy, just padding. As I said before, it's important to have a water-based chemistry. No solvent, no problem. Padding with a traditional padder, in this case a laboratory one, and after that drying. During drying, polymerization will occur and fixation to the fiber too. Drying is carried on in a traditional dryer, a Stenter. In this case, it's a laboratory one, of course. And no solvent means no troubles. And when the fabric exits, the fabric is ready. Let's see now the result of the abrasion test. Up on the top, the photos are not nice, but I hope enough clear. The upper row is an untreated silk, and down the treated silk. Well, the treated silk lasts much more. Let's say 5,000 cycles martindale against the 3,000 of the not treated one. And this performance is confirmed after 3 cleaning by soaking. The soaking is carried according to the British standard, and therefore we can say that our exclusive sofa now can last the double because we have improved the abrasion resistance. Let's stop here. No, let's see another thing, just to see some other thing interesting. So let's see photochromic pigments. It's another example application. In this case, the photochromic, we can apply the photochromic pigments to the fiber even with traditional technology, I mean acrylic. But we can do it even with sol gel, and therefore we can use the sol gel technology as against the traditional binder. The characteristic of these pigments is that they become colorated under the sunlight, while in indoor situation poor of UV, they are practically colorless. That's all. Thank you.